So before we get stuck into looking at all of the different files that are required, the most obvious thing to do is just get your generic node up online. So you can see I've switched over to the Ubuntu. I'm doing this sort of deliberately so that you can see how familiar it is. And let's open up this basic LoRaWAN and get it configured. And as I say, I'll go into the details of what each of these different files are at a later date in a different video. But for now, I can tell you that we are looking at the conf. And for reasons that I'm not entirely clear, the LoRaApp.h. I would point out that the whole LoRaWAN stack from pretty much every vendor has settings spread all over the place, and then sometimes some ginormous files with acres of code in and other files with very little in it. It is what it is. And so I'm just going to crack on, but I can show you how you might reorganize things so it becomes a little clearer where things are. So in the app.conf, we've got a couple of settings which we can just leave alone so that we get some debug output and the debugger. And we've got the sort of usual suspects in terms of OTA activation information. So let's bob over to the Things Network, and I will change my AppKey so you can all stand down. I'm going to toggle the formatting before I copy that. And this ordering here sort of is a bit of a quirk. It sort of bugs people a little bit, and that's because the official LoRaWAN stack, which is what we are currently using, or not so much the official, but what is notionally called the reference version, has all through its life had the app EUI before the dev EUI. So that explains why it's this way round on the console, which is sort of counterintuitive, because the thing that you really know that you focus on within a device is the dev EUI. So I just need to get me an AppKey. No, I need to expand that and then copy that. And as I say, I have enough test devices that if you want to go mad and copy my settings, feel free. It won't bother me in the slightest. Now, just so, not so much as a grand tour, but just so you can sort of quickly see, there are some other settings. This is the official sort of Semtech one, and this just sets up sort of various sort of different defines. There's some settings, and in LoRaWAN_conf you do need to undefine or define the right region settings that you wish it to use. So whilst I'm sort of technically able to receive 915, I am in the EU, or I'm not in the EU, I'm in Great Britain, but I'm in the EU region. So that's just one little tweak. The radio conf is entirely related to the actual radio chip, so all of that is just so much above our pay grade at the moment. And SE identity is the original file that Semtech provide. Some of the items have been copied over into app_conf, so which is why you've got a define that then redefines a define, because these are the internal defines that are used by the LoRaWAN Semtech stack. And it is worth noting that because of the changes in names, you need to be sort of boned up about using the network and application session key, which is basically at the moment don't touch them, but if you do, you need to make sure they're both the same. And then lastly, in LoRaApp, sorry, I beg your pardon, in LoRaApp.h, because the, majority of generic users are likely to have their own instance and the fair use policy doesn't apply, and or it is absolutely mandatory for all code bases to be released such that it breaches the fair use policy, you will see that it's set for 10 seconds, which is obviously a little bit brief. So I'm just going, but I am going to leave that alone for a very good reason. And again, something that I will show you how to get around, because the way the stack is set up, and this is again a sort of a fairly universal thing for the LoRa Mac node, is that after it's done a join, it waits that long before it does its first uplink. Which sort of makes sense because obviously it's got to respect duty cycles. However, it does make for some very boring debugging because you download some code, turn it on, and then you have to wait 5 minutes or some such. But so we will get around that with a very simple change, and a change that is not a hack. It's just changing one of the timer settings so that it does ascend immediately. So that's all that's required. So let us get our debug build going. I'll just get rid of the build analyzer. And you can see it's sort of chugging away here. And the build project value is always perpetually slightly wrong. It gets to about 30% and then has a think about it. And then bang, all of a sudden we've finished. As it sort of realizes a lot of code it doesn't need. So that's got that going. I've got my generic node plugged into my ST-Link, and I also have it plugged into a serial port. And there are some examples of the wiring both on the generic node website and within the forum, and I will also share details in another video. I'm trying to keep all of these things bite-sized. So let's go brave. The first time I run the Cube IDE, aka Eclipse, is just going to ask the usual questions about how things that it wants to use. And basically in debugger you should see that it has an entry that says that it's sort of going to pick up whatever your programming device is. The ST-Link in the baby form is 10 or 15 pounds, euros, dollars, however you want to translate these things, and just makes your life infinitely easier. So I'm just going to click OK, and then in the box here at the bottom you can see that it just does another build. There's some sort of haggling about getting the information. I'm just going to switch over to the debug on the serial, and we are up and running. We get some information, some of which comes courtesy of the stack, some of which is embedded in the implementation code. You see we're joining on OTAA. We have managed to do that, and we have actually sent an uplink, and we've waited, and that's all done. And then you end up with some interesting brain bumps here. Oh, so you can see it is literally going out every 10 seconds with a little bit of buffering. So the MCPS confirm is confirming that the uplink has been sent, but the message type is unconfirmed. And one of the things that I find is useful is to make the information that a little bit more useful. This whole line, very useful. Let me just stop the disconnect that for now. This line, hugely useful. This line, sort of a bit of a distraction because it's not sending a confirmed message. Let's just bob over to the website, and if we have a look at the live data, you can see that as per the README notes for the repro, we are in fact sending AABBCC. It is set to port 2. and it is sending them very, very frequently, at which point obviously you want to be switching back and perhaps putting a 3 times 60 times, and we shall make that 1,000, so that's now in milliseconds. I quite like to put brackets around my defines so that if I'd put a plus, because ideally we need to do some jitter, let's put that on port 1. There is some code that comes for free, which is a little odd, because it doesn't make it a basic stack, because it allows you to switch which ports you've got, or which class you're operating under. And just for the record, this is where you set your activation type if you want to switch over to ABP. So there's a number of things that you can explore in there, but in the next episode I will go into far more detail about where the moving parts are.